welcome to my channel Orbit of Learning by Swati Singh. So today we'll be starting up with the lecture 2 with the other topics of this chapter. We have completed the lecture 1, so if you have not seen that, do watch that. I'll just provide the link in the description. So today we'll start up with the topic measurement of length. The standard unit of length based on the metric system is a meter. To measure long and short lengths, we use special units which are as follows. Bigger units of length, astronomical unit AU. The average distance of the sun from the earth is known as 1 astronomical unit. So 1 AU is 1.496 into 10 to the power 11 meter. Light year, it's represented by Ly. The distance that light travels with the velocity of 3 into 10 to the power 8 meter per second in 1 year is known as 1 light year. So 1 light year is equal to 9.461 into 10 to the power 15 meter. Next one is the parsec. The distance at which average radius of Earth's orbit around the sun subtends an angle of 1 arc second is 1 parsec. That is, 1 parsec is 3.08 into 10 to the power 16 meter or 3.26 leap year. So these are the smaller units of length. You can even get this chart in my shorts also. So you can go and see my shorts also. Many more tables and things are there also. So you can just take the screenshot or you can just watch it in my shorts. So the next topic is measurement of mass. Mass is the basic property of matter which does not depend on temperature, pressure or location of the object in the space. These are the two tables, bigger unit of mass and the smaller unit of mass. You can take the screenshot or even it will be provided in my shorts even. So next one is measuring mass. We commonly use the term weight, which is actually the mass. The SI unit of mass is kilogram, as we have studied previously in the table. We buy gold in grams or milligrams, medicines in milligrams. There are different types of balance scale: common beam scale, physical balance, digital balance and spring balance. So now here we'll see the difference between mass and weight. Mass, it is a fundamental quantity, and weight, it is a derived quantity. Next, mass, it has magnitude alone scalar quantity. Weight, it has magnitude and direction vector. Next, mass, it is the amount of matter contained in our body, and in weight, it is the normal force exerted by the surface on the object against gravitational pull. Next one is the remains the same everywhere. Mass remains same everywhere, but weight varies from place to place. In mass, it is measured using physical balance, and it is weight is measured using spring balance. Mass, the SI unit is kilogram, and the weight SI unit is Newton. Next comes the measurement of time. To measure any time interval, we need a clock. The clock, which is based on periodic vibrations produced in an cesium atom, is known as cesium clock or atomic clock. It is used in the national standards. Some base units based on this clock are as, so you can see bigger unit of time and the smaller unit of time. You can just take the screenshot even. Practical units, these are the practical units. I'm not reading it out. You can just take the screenshot. So here the unit of pressure, unit of energy and the unit of power. Next one is the errors in measurements. What are the errors in measurements? Generally, measured value of a quantity is different from the true value of the physical quantity. The difference between the true value and the measured value is called the error. Error क्या है? True value और जो measured value के बीच का difference होता है उसको हम error बोलते हैं. So this is the formula for error, which is true value minus measured value. In general, the error is measured can be broadly classified as systematic error or random errors. So first we'll see the systematic errors. The errors that tends to be in one direction, either positive or negative. Instrumental errors that arise from the errors due to the imperfect design or calibration of measuring instruments, zero error in instrument, etc. Example is the temperature graduations of a thermometer may be inadequately calibrated. Next is the imperfection in experimental technique or procedure. To determine the temperature of human body, a thermometer placed under the armpit will always give a temperature lower than the actual value of the body temperature. Other external conditions during the experiment may systematically affect the measurement. Next is the personal errors. The personal error that arise due to an individual's bias, lack of proper setting of the apparatus, or individual carelessness in taking observations without observing proper precautions. Least count errors. Least count error is the smallest value that can be measured by the measuring instrument. The error associated with the resolution of the instrument is called the least count error. What is random error? The random error are those errors which occur irregularly and have random with respect to sign and size. These can arise due to random and unpredictable fluctuations in experimental conditions. The next one is the absolute error, relative error, and percentage error. First one is the absolute error, the magnitude of the difference between the individual measurement and the true value of the quantity. It is always positive. You can have a look for the formula. Relative error, it is the ratio of the mean absolute error to the mean value of the physical quantity. And this is the formula. You can just represent relative error in this. Percentage error, it is the relative error expressed in percent. Percentage error is defined as this term. We'll just multiply with 100 for getting the percentage. Combination of errors, error in sum of two quantities. If a physical quantity x can be expressed as the sum of two physical quantities a and b, as x is equal to n, the error in x will be delta x plus or minus delta a plus or minus delta b. Error in product of two quantities, x is equal to a into b, then the fractional error will be in this form. एरर इन डिवीजन ऑफ टू क्वांटिटीज़, अगर डिवीजन में एरर आता है तो ये किस वे में रिप्रेजेंट करता है, इस वे में, डेल्टा एक्स अपॉन एक्स प्लस माइनस डेल्टा ए प्लस माइनस डेल्टा बी अपॉन बी. Hence relative error is in the result when two quantities are multiple on divided is the sum of relative errors. Next one is the error in the power of quantities. If x is equal to a की power m, b की power n upon c की power r, then the relative or fractional error in x will be delta x upon x is equal to plus or minus m, delta a upon a plus n, delta b upon b plus r, delta c upon c. Significant figures. Significant figures indicates the precision of measurement which depends on the least count of the measuring instruments. Rules to determine the number of significant figures. All non-zero digits are significant. 235.75 have 5 significant figures. All zeros between two non-zero digits are significant. 2016.008 has 7 significant figures. See, these are 4 and these are 7. So, total significant figures are 7, right? All zeros occurring between the decimal point and the non-zero digit are non-significant. Provided there is only 0 to left of decimal point, 0.00652 has 3 significant figures. Decimal के बाद जो भी 0 figures होंगी non-zero वो count होंगी as a significant figures. All zeros written to the right of non-zero digit in a number written without a decimal are not significant figures. This rule does not work if the zero is the result of the measurement. 54,000, 2 significant figures, 54,000 m, 5 significant figures. All zeros occurring to the right of a non-zero digit in a number written with the decimal point are significant. 32.2000 has 6 significant figures. When a number is written in the exponential form, the exponential term does not contribute towards the significant figures. 2.465 into 10 to the power 5 has 4 significant figures. Rules for arithmetic operations with significant figures. In the arithmetic operations involving significant, the answer is reported in such a way that it reflects the reliability of the least precise operation.
In addition and subtraction, for addition and subtraction, look at the decimal portion of the decimal. It follows the following procedure. Count the number of significant figures in the decimal portion of each problem. Add or subtract in normal fashion, right? In multiplication or division, the final result should retain as many significant figures as are there in the original number with the least significant figures. Next one is the rounding off. Rule of rounding off of the uncertain digits. The preceding digit is raised by 1 if the uncertain digit to be dropped is more than 5, and it's left unchanged if the latter is less than 5. So for example, it's 5.686. राउंड ऑफ करेंगे इसको तो क्या हो जाएगा, 9 हो जाएगा, ठीक है. इसमें क्या करेंगे, राउंड ऑफ करेंगे तो ये 5 से छोटा है तो इसको जो है हम 4, 6 ही काउंट करेंगे. If the uncertain digit to be dropped is 5, the preceding digit is raised by 1 if it's odd and is left unchanged if it is even digit. Example, 7.735 is rounded off to 3 significant figures. 7.74 as preceding digit is odd. 7.745 is round off to 7.74 as preceding digit is even. Next one is vernier caliper and screw gauge. Vernier caliper, a vernier scale which is named after Pierre Vernier, is defined as a visual aid to take an accurate measurement reading between two graduation marking on linear scale by using mechanical interpolation. It is used to calculate the internal and external diameters of hollow cylinders. I think this will be hollow cylinders hoga. It is also used for the measurement of diameters of round objects with the half of the measuring jaws. First one is the least count. Least count कैसे count करते हैं? Value of one main scale division upon total number of vernier scale division. Zero error. Unscrew the slider and move it to the left such that both the jaws touch each other. If they do not coincide, then the instrument is said to possess zero error. Zero error may be positive or negative. Right? Next one is the screw gauge. Screw gauge is an instrument that can measure the dimension up to 1/100th of the milliliter or 0.041 mm. With the screw gauge, it is possible to measure the diameter of a thin wire and thickness of thin metallic plates. बहुत कम जो थिकनेस होती है उसको स्क्रू गॉज से हम मेजर करते हैं. द स्क्रू गॉज वर्क्स ऑन द प्रिंसिपल दैट व्हेन अ स्क्रू रोटेट्स इन अ नट, द डिस्टेंस मूव्ड बाय द टिप ऑफ द स्क्रू इज डायरेक्टली प्रोपोर्शनल टू द नंबर ऑफ रोटेशंस. First one is the pitch of the screw. The distance moved by the tip of the screw for one complete rotation of the head. So it is equal to 1 mm in typical screw gauge. Pitch is equal to distance moved by the pitch upon the number of rotation by the head scale. Next is the least count of screw gauge. Least count of screw gauge, which is represented by LC, is the value of one smallest scale reading upon the total number of head scale division. Next is the zero error of a screw gauge. When the movable stud of the screw and the opposite stud on the frame area brought into contact, if the zero of the head coincides with the pitch scale axis, there is no zero error. Division of physical quantities. The dimension of physical quantities. The dimension of physical quantity are the powers to which the fundamental quantities mass, length and time must be raised to represent. Momentum is equal to mass into velocity or mass into length upon time. So the dimension is written as ml upon t, ml to the power minus 1. Hence the dimension of momentum are 1 m mass, 1 in length and 1 in time. Dimension formula and dimensional equations. The expression which shows how and which fundamental quantities represent the dimension of a physical quantity is known as dimensional formula. Example, the dimensional formula of the volume is m0 L3 T0 and that of speed or velocity is m0 L T to the power minus 1. An equation obtained by equating a physical quantity with its dimensional formula is called a dimensional equation of the physical quantity. dimensional equation of energy. So energy is equal to force into displacement. So the dimensional equation will become ml ki power minus 2 t ki power minus 2. So what's the application of dimensional analysis? To find the unit of a given physical quantity in a given system of units. To convert a physical quantity from one system of unit to another. To check the dimensional correctness of a given physical relation. Deducing relation among the physical quantities. What are the limitations? To derive a physical relation, we must first know the what factors the given physical quantity depends, and after that we can derive only the primarily relations of the product type, such as T is equal to K under root L upon G. The value of dimensionless contact appearing in formula cannot be determined by this method. So this is some extra facts from Tamil Nadu board and NIOS. The nearest star Alpha Centauri is about 1.34 per second from the sun. Most of the stars visible to the unaided eyes in the night sky are within 500 per second distance from the sun. So here we have completed this chapter. So we have just completed in the 2 lectures. So next chapter will be coming up in the lecture 3. So if you have not seen both the first part also and this part also, so go through it for the chapter 1. So if you're liking this series, please share, and if you like this video, please like, share and subscribe my channel for more such videos.